When you hear the word machine, what's the first thing that pops into your head? Probably gears, right? Or engines, computers, stuff designed and built by human hands. But what if I told you the most powerful, most complex, and honestly, the most elegant machines on Earth weren't built by us at all? They are all around us, operating on principles we're only just starting to wrap our heads around.
So over on the left, that's our typical idea of a machine. But for this explainer, we're going to shift our focus entirely to the right. We're going to expand that definition to see the machine in a leaf that's turning sunlight into fuel, in ocean currents that literally regulate our climate, and yeah, even in entire ecosystems that build themselves from the ground up.
So what are we really talking about when we say natural machine? Let's get a working definition down. It's a system that runs all on its own. It hasn't been designed by some engineer in a lab. It's been shaped by the fundamental laws of the universe over millions, sometimes billions of years. It doesn't need us to maintain it or even to understand it. It just works.
All right, let's begin our little expedition. It's time to pull back the curtain and uncover these hidden machines that are operating silently all around us, powering our world in ways we barely even notice.
Let's keep this question in the back of our minds as we go on a journey of scale. We're going to start with the infinitesimally small and zoom all the way out to the planetary level to see if we can find the answer. So, our first stop is the molecular level. This is home to one of the most sophisticated and absolutely life-giving engines on the entire planet.
And that engine is photosynthesis. Yeah, I know, we all learned about it in school, but let's look at it in a totally new way, as a perfectly tuned, microscopic biochemical machine.
You see, this process isn't just some random chemical reaction, it is a precision assembly line. It all kicks off when pigments like chlorophyll capture photons from the sun. Next, that light energy gets converted into chemical energy. We're talking molecules like ATP. And finally, that chemical energy is used to build sugars for food, releasing the very oxygen we breathe as a byproduct. It's a flawless, self-replicating energy conversion system.
And the impact of this tiny machine? Well, it is anything but small. Get this. Photosynthesis powered the rise of atmospheric oxygen and transformed Earth into a habitable planet. Just think about that for a second. A single molecular process literally terraformed our entire world and became the foundation for pretty much every food chain on Earth.
Okay, now let's scale up from molecules to living organisms that act as machines themselves, engineering entire landscapes.
Our next example is the beaver dam. You've probably seen one, right? But have you ever really thought of it as a machine? Because this isn't just a pile of sticks. It's an incredibly sophisticated piece of hydraulic engineering. Once it's built, the dam just goes to work on its own. It's a hydraulic regulator, slowing down rivers, preventing erosion, and refilling groundwater tables. This whole process creates entirely new wetland habitats, which boosts biodiversity, and amazingly, it creates conditions in the soil that store carbon even more effectively than the forests around it. The beaver is the engineer, sure, but the dam is the machine that runs all by itself.
All right, it's time to zoom all the way out to the planetary scale, where we find these massive, world-shaping engines that govern our entire globe.
First up is the global ocean conveyor belt. Think of this thing as a planet-sized pump. It's a massive system of currents, driven by simple differences in water temperature and saltiness that circulates heat all around the globe. It is, quite literally, Earth's climate engine.
This chart really puts its power into perspective. See that smaller bar? That represents the total annual energy moved by all of humanity's infrastructure combined. The larger bar, that's the ocean conveyor belt. It's not even close. This single natural machine moves more energy than all our power plants and grids put together, and it moderates our planet's climate completely on its own.
You know, another one of these planetary machines is plate tectonics. We usually think of it as the thing that causes earthquakes and volcanoes, but it's way more accurate to see it as this vast, slow-moving recycling system for the planet's crust.
This entire system is self-regulating, powered by the immense heat boiling up from Earth's core. As it constantly recycles rock, it plays this absolutely vital role in regulating carbon dioxide in our atmosphere. It's a geological feedback loop that acts like a planetary thermostat, keeping Earth's temperature stable over millions and millions of years.
So, we've seen these machines at the molecular, ecosystem, and planetary scales. What does it all mean? What can we really learn from nature's incredible engineering genius?
Well, the intelligence behind these machines isn't that of some conscious designer. Instead, it's a profound intelligence embedded not in minds, but in physical laws and emergent systems.
It's an intelligence that's just woven into the very fabric of the universe itself.
And when you think about it, so many of our own greatest inventions are just echoes of these natural blueprints. Our solar panels, we're just trying to replicate the efficiency of photosynthesis. Our industrial recycling systems, they mimic the logic of plate tectonics. Even our communication grids have parallels in the vast fungal networks under our forests. We are, in so many ways, just playing catch-up.
And that leads us to a pretty powerful takeaway. The concept of the machine, it wasn't ours to begin with. Nature was the original engineer, and for all our ingenuity, we are still just students, learning from its incredible designs.
So I'll leave you with this to ponder. As you look at the world around you, at the forests, the oceans, the ground beneath your feet, ask yourself, what other incredible machines are out there, just waiting for us to discover them? And what other blueprints can we learn from?